Okay, so we are looking at sine law and cosine law of double triangles. We just finished up learning sine law and cosine law, and then spending a day practicing choosing between the two different laws. So when you use sine law and when you use cosine law. So hopefully we've got that nailed. And now we are looking at some double triangle questions that involve non-right triangles. Now they'll have right triangles as well, as you can see this one does. And this is similar to what we did earlier in the unit where we did double triangles but with right triangles only. Okay, this time we have non-right triangles involved as well. And the one thing that we know about double triangles, any question that involve, and we're going to see applications as well that involve two triangles, okay, um, or more than one triangle, I should say, because often it's actually three triangles. If you're looking for the three here, it's this one, and this big one as well, right? So this actually has three triangles, but we just call them all double triangle questions. And the first thing we want to know about them is you can't solve for what you want to find directly. Okay, so we're trying to find x, but it's almost certainly in our course, definitely it is going to take more than one step to find x. So the trick is analyzing the information we already have, what things, side lengths or angles, it allows us to solve for, and then which of those things are actually useful. And there's sort of two approaches. That's one of the things that you can start with, is looking at the information that you're given and thinking about what you can use that to solve for. What could you find? And there's a whole bunch of things we could find. And from all those things, we can decide what of those things is useful. The other thing you might do is you might say, well, what would I need to solve for x? That's the other question that you could ask. What if I had certain measurements, I could find x, and then you say to yourself, are those things I can find? Okay, so I can't find x directly, but for example, what if I knew this side length? Then could I find x? What if I knew this angle? Then could I find x? What if I knew this side length? Then could I find x? And so on. And it might be more than one thing. Okay, so those are sort of the two main places that I would recommend starting. Look at what you have and what it can find with it, or at the same time, one or the other, whichever one works better for you. People are going to definitely see it different ways. Which, if you're looking for X, what would be helpful? If I knew A, B, C, then I could find X, something along those lines, okay? And then, of course, all of your skills involving all these things are going to be helpful. So one thing that I often think of is in a triangle, if I have three things, then I can solve for something else. And we talked about this for sine law, cosine law, and choosing between them. You need three things. And if you have four things, it's going to be different. But if you only have three things, then you are definitely using either sine law or cosine law, one or the other, not both, right? In some cases, you're going to be using sine law, in others, you're going to be using cosine law. So you don't get to choose. And so for example, in this case, we're given three measurements. They are all in the same triangle. It might not be super obvious, but this is the triangle that those are all measurements of. And so that means to solve for anything else in this triangle, I'm either doing sine law or cosine law. So I have to figure out which the correct one is, okay? So that is another thing to think about, is look for where do you have three pieces of information, okay? And that's going to tell you definitely where you're starting. So we're going to do three examples. Let's get into this one, and hopefully as we're going through that stuff that I'm talking about will start to make more and more sense. And after we've done a couple of examples, you see what I mean by those little tips of how to start. Now, often with this one, I find students notice that I can solve for a lot of the angles in this question. So I could find this angle, I could find this angle, and with a bit of work, I could also find that angle. So in fact, I can find every other angle in this question without doing any trigonometry, just using the properties of of triangles, angle sums and triangles, or in this case, it's a supplementary angle, right? So these two angles, a flat angle is 180 degrees. That's something that we know from grade 10. And this is a flat angle, a straight line. So the two angles here, this angle and this angle, have to add up to 180. So that means I can do 180 minus 135 to give me the 45 that goes here, okay? And this isn't a terrible thing to do. If you can find all the different angles, it's not a bad idea. As I just said, sometimes you're not sure exactly how to proceed, what the first step is or what the next step is. So you can ask yourself, well, what can I find? And then maybe you go and find it and you label it in the diagram and see if that helps. If you're not sure what else to do, it's not a bad thing. And like I said, I could go ahead and I could find all the other angles, but I may or may not need them. That's the thing. So if you don't know what else to do, great idea, go for it. But I'm going to stop, and instead of finding all the angles, I'm going to stop there, and we'll wait and see if we need the other ones, and we'll calculate them when we do. And the only reason I'm doing that is because I also want to stress that with these questions, you do need to come up with a plan. You do need to figure out what the steps are in order to find what we're solving for, which in this case is this side length x. And randomly trying things until we get the right answer isn't the most efficient way of doing it. If you don't know what else to do, like I said, start finding things. Don't waste your time staring at a page and doing nothing. That's for sure. But the best thing is if we can actually figure out what to do and just do those steps instead of randomly trying things and wasting time. Okay, like I said, it's not a bad thing, especially finding angles. It doesn't take a long time. That only took us a few seconds to find this angle, so that's fine. But if I can figure out exactly what to do, that's better. So the other thing that I haven't said yet is if you're unsure, if it's not clear, and it probably won't be when you're first starting a question, right? Exactly what the steps are. You want to look for side lengths that are in both triangles or angles that are in both triangles or that kind of thing. Okay, so as I said, this triangle, we have enough information to start solving for things. And this triangle shares a side length with this triangle, right? So if I trace out that triangle and then I trace out this triangle, look what happens. They share that middle side length. And if I can figure out what this side length is, okay, this length right here, then I have an angle and I have a side length, and I can use that to find another side length, because in a right triangle, that's what I need. In the right triangle, I've got the 90 degrees, I've got another angle, so I can use that to find the side length that I need. So that gives me a purpose, that gives me a focus. Can I find this side length? Another thing that's really useful, we talked about this before, I think, is redrawing the triangle separately. So I'm going to redraw both of these separately. Okay, this is my x. We've already found this, it's 45 degrees. I don't know what this side length, I don't know any of the other side lengths. I'll just leave it at that. Here's the other one. Okay, this is 135. This is the same, I'm going to call it y for now. Okay, so this is the same side length. Those two are the same. Okay, this is 30 and this one's 8. So now, just looking at this triangle, am I able to find that side length? Because if I can, that's this one, and I can use that to find x. And we almost can. We actually need one more thing in order to find it, because I have one angle and side length across from each other, and we know that's sine. So this angle 8 is across from 30. These wedge kind of leaning triangles do make it more difficult to tell what's across from what, but the 8 is across from the 30. So that's starting to look like sine law. But what is across from y? This one here, which is empty, right? I don't know that one yet. But if I have two angles, I can find three. So that, again, is this angle. And I can use the other two angles to find that angle. So I'm going to go ahead and do that. So 180 minus 35, 135, sorry, minus 8. And that works out to 37. So I'm going to go ahead and put that in there as 37 degrees. Now just let me stop. If I didn't know what to do, I might have found that anyway because I found the 45. Maybe I find the 37. Maybe I go ahead and find this one. And then from there start thinking about what I have to do. But I've already realized that with this angle 37, it's across from that side length. And now I can use sine law to find this side length, which I called y in the other triangles that I drew. And when I find that, I can use that to find x using SOHCAHTOA in the right triangle. That's a lot of steps, I realize that. But if you need to go back over it, rewatch that part of the video and follow it through again, and recognize that there's no one way of doing these, and different people will see them differently. So some people might recognize that as a shared side. And because it's a shared side, it means that if I can find it, it might be helpful to find the x. Okay, that's one way of thinking about it. Another way of thinking about it is, well, it's just what I can find. And if it's all I can find, then I might as well go ahead and find it, right? That's another way of looking at it. So no matter how you decided that it was a useful thing to try and find, once we've realized that that's what we're going for, now we have to figure out exactly how to find it and just go through those steps. So in this case, like I said, I'm using sine law and I'm looking for an angle. And I like to organize my solutions by doing things like labeling and saying, giving a little title. And this is like when we were solving triangles. So I'd give it a little title. This is for y. So I'm solving for y. Okay. And I'm solving for a side length and I'm using sine law. So it's a over sine a equals b over sine b. I'm using this version because it has side lengths on top. One of my side lengths is y. The angle across from it is 37. The other side length is 30. Whoops, not 37, sine of 37, because it's an angle, over sine of the angle across from that, which is 8. Okay, so again, the 30 is across from the 8, and the y is across from the 37. Now I'm going to stop there. The hard part of these questions is hopefully figuring out what to do. The actually doing it part is what we've been practicing up until now. So hopefully we're confident with that. It's the doing part. Once we know what to do, hopefully we can do it. It's figuring out what to do. I recognize that's the harder part. And so that's what you want to be focusing on while you're doing this practice, is coming up with that plan and thinking about it. And I recognize that it's hard, and you might have watched through me walking you through this and kind of be like, I still don't really know what you're talking about. I get it. It might take some time. So all you have to do, like I said, you can rewatch it or you can wait for the next couple of examples and it might start to click, and then you have to start trying some on your own. These problem solving questions, sometimes watching somebody else do them and explain what they're doing isn't the best way to figure it out. You have to try on your own. But I gave you 3 different strategies of how you can start your thinking. If you need to write those strategies down, do it. And when you're starting a new problem, look at those 3 strategies and decide which one you're going to try, and just try it, right? People find problem solving hard because they don't know where to start. So you have to tell yourself, well, what if I try this? How would that work? And then you just have to give it a shot and try it. And if that doesn't work, then you can always just try something else. Okay. Okay, so I'm still finding y here, and I'm going to rearrange this. And I am going to go 30 sine 37 close bracket divided by sine 8 equals. So I'm going to keep a whole bunch of decimal places, 129.72658. I'm keeping 5 decimal places. You could write the whole thing down actually if you really want to. It's not a terrible idea. But I'm just going to write down those 5. But what I'm actually going to do is I'm going to leave it on my calculator. And I'm going to use that answer when I go to solve in the next triangle. And that way I'm not rounding at all. We've talked about this. There are occasions in the real world where you need to be exact, you need to be perfect, and it's good to know how to do that. I think why not challenge yourself and learn how to do that and just try to make your answers exact, okay? That being said, if you're off by 1 or 2 decimal places because of rounding, uh, it's not going to be the end of the world for this course, okay? There are other courses where we expect you to be perfect, but in this course, I'm going to let you be off by a few decimal points if you round, okay? But the best thing is to learn how to just keep it on your calculator and be exact. So now that I have y, now I'm going to be able to solve for x. And I'm going to redraw this triangle again just so that we can, oh, I already did it over here, didn't I? Yeah. So I've got it drawn over here so we can visualize. And for sine or for right triangles, it's SOHCAHTOA, right? So I'm figuring out which one it is. And we label the triangle to do this. That's hypotenuse. This is the angle we're using. And so the side length we're looking for is opposite. So I'm looking for opposite, and I have the hypotenuse. It looks like it's unknown, but we figured out what y is, don't forget. So which one is opposite and hypotenuse? Sine. Okay, so for x, I'm using sine, but not sine law. I'm using sine theta is opposite over hypotenuse. I'm using right triangle trigonometry, and you are required to do this when you can, okay? Don't use sine law or cosine law in right triangles. For this course, you have to use SOHCAHTOA, okay? I want you recognizing when it's a right triangle and using SOHCAHTOA for those, and when it's not a right triangle, that's when you use sine law and cosine law. So sine of 45 equals opposite, which is the x that I'm searching for, over y, or hypotenuse, which is actually this value, 129.7. So I'm just going to write down a shorter version of it there. That's fine. You don't have to write down all 5 decimal places again. So now 129.7 times sine 45, again, this is something that we did before, equals x, and x equals, and here's where I still have that answer on my calculator. So I'm just going to go times, and it's going to say answer times sine 45, okay? And that gives me 91.7. We're going to round it to 1 decimal place because it's a side length, and we're talking meters here, so I'm going to put meters as units in my answer, okay? And that's how I can use the rounded answer, or the answer that I found before. That's how I can use it, by just hitting times. If you don't have a calculator that does that, then you're going to have to write down all of the decimal places, 4 to 5 decimal places, punch them back in to solve. I'm going to see what happens if I do that. 129. What if I just use 129.7 times sine 45? Let's see how far off that would be. Not very far off. It's still 91.7. So in that case, and we saw this before, you'd get away with the answer. What if I used 130? What if I rounded to that? Sine 45. So now it's 91.9 instead of 91.7, so it's a little bit off, and you can see when you round, you will be off by a little bit. If you get off by way too much because you rounded wrong or something, then you may end up losing marks, right? But I do want you to try, if you can, to do this and use the answer and see if you can get exact to avoid rounding. Sometimes even if we sort of round and round properly, it can make our answer very different, so we have to be careful of that. Okay, so that was one of the examples where, again, I've got two triangles, and I recognize that in this smaller triangle, I was able to use the information I was given to find y, and that was useful because that's a side length in this triangle, and that allowed me to solve for x. Some people often notice in this particular question that you could have also solved for this side length, and that's true. You could have. And then you could have used the bigger triangle as a right triangle and solved for x that way. So there are two slightly different ways that you could solve this question. I could find this side length, or I could find that side length. And both will allow me to find x in the end. So sometimes there will be multiple ways of doing these. One's not better than the other. I did it the way I did it just because that's how I did it. There wasn't a better reason. All right, let's try another one. B. So this one is not three triangles. It's two triangles and looks like a quadrilateral. And we don't really know anything about quadrilaterals, so we're not going to do that. We're going to do everything with two triangles. I notice that I'm given a lot of information up here in this top triangle. So I'm going to analyze what information I've been given by redrawing it and labeling. And I notice that this is cosine law. And because it's two side lengths and the contained angle, the angle between them. And that allows me to find what? The other side length. Okay? And that's all it allows me to find. I can't find anything else. This is one of the things I was saying before at the very beginning, before we started that first example, is you might look at this and say, that's all I can do. I can't find the other angles yet. I can't find anything in the other triangle yet. The only thing I can find with these three pieces of information that I've been given is this side length, right? That's the only thing that I can find. So I'm going to have to find it. But if I take a second look before I actually find that and I realize, hey, that is the side length that's shared between the two triangles. And that's going to allow me to have an angle and one side length to find another side length in this right triangle. So sure enough, that's the only thing I can find, but that's what I want to find. Okay, so how about this time I'm going to call it A. No reason, just decided to, and I'm going to say for A, I'm going to use cosine law, and that's c squared equals a squared plus b squared minus 2ab cos of c, the angle that's contained. And I'm using that version because I'm looking for a side length, and that's the version that we need for finding a side length. Okay, so A was maybe a bad choice, although it allows us to talk about this again, because A is in this formula. That's not the same A. This A is actually going in for the C. So if that's confusing, pick a different variable and use that instead. Okay, I'm going to leave it to give us something to think about. So a squared is actually the 25. Doesn't matter which one's which, but I'll say a is 25 and b is 32. I could have made them switched. Minus 2 times 25 times 32 times cosine of the angle that I have, 125. Don't get yourself confused and use 62. That's not even in the triangle. That wouldn't make any sense. Okay, and I'm taking the square root of this and I'm writing that in so I don't have to write it out twice, because it is actually c squared, which means you end up taking the square root of it. Okay, so again, I'm going to put this into my calculator. Square root 25 squared plus 32 squared minus 2 times 25 times 32 times cos of 125, got to close that bracket, equals 50.66283. Okay, so again, I kept 5 decimal places, but I rounded the 2 up to a 3 because of the 9 next to it. Okay, I'm going to leave that on my calculator and I'm going to actually use that answer, but I've written out a rounded version to 5 decimal places just in case. If I somehow lose the memory on my calculator and I have to come back, I can check and I can just punch that in, and 5 decimal places, generally speaking, is going to be good enough for it to be perfect. So now I have this triangle, okay, and I've got 62 here, and I found this to be about 50.7, 50.66. How about I write that? 66. I'm looking for x, and this is a right angle. And now I can do this as hypotenuse. Okay. This is opposite, which means this is adjacent. So for x, again, remember, now I'm doing SOHCAHTOA because now it's a right triangle. So this is cosine, because cosine is adjacent over hypotenuse. So cos of 62 equals adjacent, which is x, over hypotenuse, which is 50.66, but I'm going to use that on my calculator. And this is the part that hopefully we just know how to do, the solving part. So I'm using this, and again, I'm going times cosine of 62. And that gives me 23.8, 23.78, which is 23.8 centimeters. Okay. So this time was a little bit different. It was more obvious what to do in this case than in the first one, I would say, because I had these 3 pieces of information, and the only thing I could find was this side length that I called A, and that allowed me to solve for the next step for X, right? Um, Again, the other possible steps are asking yourself, well, what would be helpful for X? And if I went back and did that, I could say, well, I'm looking for a side length and I've got an angle. So all I need is one more side length. So I either need this side length or I need that side length, right? And you could say, if I had one of those, I could find X. And then you might say, well, this side length is shared, so it's probably more likely I'm going to find that one. And you might say, well, this side length, how the heck would I find that? I don't know anything about it. It's not close to those, it's not even in the triangle with those. So you'd say, I probably am not finding this, and I'm probably finding that. And hopefully you would have been on the same track that we were on when we did this, right? So again, the 3 different sort of approaches are, what can I find given the information that I have? What would be useful to find that would help me find X? And you might do a bit of both put together, maybe, right? And then the other thing is, what sides are shared, and can I find, or angles, what angles are shared, and can I find those, and would that be helpful, right? So there's obviously a crossover between all 3 of those sort of questions that you're asking yourself, or approaches, or strategies. But explicitly thinking about it, I'm going to try this one. I'm going to see what information I'm given and what I can use it to find. Um, uh, Redrawing triangles and labeling them is another tip that can be helpful. It can help you narrow down, or more easily picture what it is that you can find. Okay. Before we move on, I'm going to see what would happen if I used a rounded version of this. So let's say I use 50.7 times cos of 62. This is really good to do just because it allows us to see what rounding does and why we're careful about it and that sort of thing. And eventually you get an idea for when it's important when it's okay to round or when it's important not to round, right? It's not something that we do very often. So again, that would give me 23.8. This one was 23.78. It's rounded up to 8. This one was 23.80. So if I was taking 2 decimal places, these answers would be fairly different, 23.78 and 23.80. So to 2 decimal places, it wasn't enough for me to round to 50.7. What if I rounded wrong to 50.6 times cos of 62. Okay, then I'm off, although rounding to 1 decimal place, I'd still get the right answer. And what if I rounded to 51 cos 62? Then 23.9, so that would be wrong to 1 decimal place. So again, rounding may or may not matter. That's a tenth of a centimeter. That's not very much. That's not very far off. That's not really the point. We talked about this before. The point is knowing when your answer is perfect, when it might be off by a little bit, and I guess having a sense of how off might it be. Like, could it be really, really wrong, or is it going to be just a little bit wrong? And then it always depends on what you're doing as well. If you're building a rocket ship, it's pretty important to be perfect. If you're building a birdhouse, you probably don't have to worry about it too much. Okay, so A and B are the two important examples that I really want you to focus on and understand how to do. And if that's enough for you, you might want to stop there. This one has more steps to it. So I'm going to do it. I'm going to do it a little bit more quickly. If you want to pause the video and think about the things that I say and try to follow along, that's not a bad idea. But this one is going to be a little bit more challenging. So if 2 examples is enough and you think you can try it on your own, you can stop now and go try the practice on your own. Most of the questions will only be 2-step questions and more straightforward, but this one is going to be a little bit more of a challenge, and I'm going to go ahead and try to solve it right now as well. But I am going to maybe go a little bit more quickly through it. Okay. So I'm trying to find x. X is in the top triangle, and all I have is 2 angles in the top triangle. Okay. If I have 2 angles, I can find the third. So I'm not going to find it yet. If I need it later, I'll find it. But I'm making a mental note that I could find it. Okay. But I don't know any side lengths in this top triangle. So I know I'm not starting there. And with these double triangle questions, that's never really the case. So I know I'm not starting there. So I'm going to move to the bottom triangle. I'm also going to make a mental note that they share a side length. And if I could find that side length, that's the only thing that they share. So it's probably a good indicator that that's what I'm going to find. If I was going to find that side length, I would need 2 sides and the angle between them. Then I could use cosine to find that side length, which we did in the last question, but I don't have that, so that's not what I'm doing. If I had an angle and a side length across from it, and I had this angle, then I could also find that. But I don't have that because I don't have that angle. So something maybe seems a bit off here. But this is a case where you're going to say, well, what can I find? Okay. And sure enough, I have an angle and a side length across from it. So I'm definitely using sine law. Okay. But the other thing I have is a side length. And what's across from that? That angle, which means that's the only thing I can find, and that's the thing I'm going to find. And I'm going to call it theta, and I'm going to go ahead and find for theta. What if that's not useful? What if that's not what I'm supposed to do? Well, you may not be convinced, but I'm already fairly convinced that's the only thing I can find. Okay, yes, I could find this angle, but that's not going to help me go another step afterwards. The only thing I can find in this bottom triangle with the 2 side lengths and an angle is this angle. So that's what I'm going to have to find. Okay, so for theta, this is going to be sine A over A equals sine, B over B. And this is sine law, but with angles on top because I'm looking for an angle. So sine theta over the side length across from it equals sine 71 over the side length across from it. Okay, sine theta equals 142 sine 71 over 162. Theta is approximately shift sine 142 times sine 71 close bracket divided by 162. And I did the shift sign because I'm looking for an angle. if I didn't do that, 0.97443. Let's say I didn't do that and I just did 142 times sine 71 bracket divided by 162. I'm going to get some weird decimal. I'm going to know that's wrong. And I'm going to say, whoops, I forgot to do shift sign. So now I'm doing shift sign of that decimal, and it gives me the same answer. Here's something to think about. When you round an angle and use it, it's probably going to make a way bigger difference than the last two questions where we were rounding side lengths. So if I rounded this to 56 and use that, I bet you my answer is going to be a lot further off than in the questions A and B that we've already done. So I am not going to do that. But we'll maybe again show an example of that and see how far off it gets us. I don't know that it'll be far off, but I'm guessing it'll be worse. But I'm going to try to keep this answer on my calculator and use it all the way through. Now, I've got theta. That still doesn't help me. Remember, we had two options. If I knew this, I have two side lengths and the angle between them, and I could use that to find the angle, the side length across. Or if I want to use sine law, I still need this angle to find that side length. But in that case, I would just use sine and use an angle and a side length pair that are already across from each other. So I could use either, but either way, I need to find this. So I need to find this angle. So I'm going to label it. That's an alpha. That's another Greek letter that we often use for angles. You don't have to use alpha. If you just want to use A, B, or C, that's fine. Use whatever you like. Okay. So I'm using alpha. So now, and I'm going to do it down here because it's not going to be too long. 4 alpha. Okay. And for alpha, I'm just doing 180 minus 71 minus theta, which is that 55.97. But I'm going to do 180 minus 71 minus answer. So that is 53.02557. Okay. Okay. Now I know alpha, and I'm going to use sine law again to find this. I'll call it y. So I'm going to come over here and I'm going to go 4y. Sine law, looking for an angle on top, or sorry, side length. So side length on top. The side length I'm looking for is y. The angle across from it is alpha, which is 53.0. Okay, but I've got that on my calculator. Equals b. I'm going to use the side length and angle that I'm given, not the one that I calculated. I'm not going to use that, theta. I'm going to use 71 and 162. Okay, so 162 over sine 71. Y equals 162 times sine of 53.0 over sine 71. All right, 162 sine of my answer. That's the 53.0 that I had left in my calculator, divided by sine 71. 136.87987. Okay, 87986 rounded up to a 7. Whoops, that's a weird looking 7. And finally, I have a side length in the triangle with the x, and now I can find x. Although before I even do that, now it looks like I have to find that angle that I talked about in the very beginning, because I need a side length and an angle across from each other. So you don't have, when you're solving these angles, we've talked about this before, you don't have to do a whole step and give it a label. I can just do this, it's 57, and write it in. That's fine. That's not rounded, it's exact because all I was doing was subtracting. So it's fine to use that one. And as my final step for x, I'm doing sine law again, x and 41 across from each other, and y and 57 across from each other. You can see what I mean by this one has a lot more steps than the last two examples. So this again is going to be a over sine a equals b over sine b. And I'm looking for x over sine of the angle across from it, which is 41, equals b, which is my y, which I just calculated, 136.9 over sine of 57. I'm going to rearrange this. 136.9 sine 41 over sine 57. Okay, now I don't actually have, whoops, I don't have this 136 in there anymore because I subtracted to get 57. So I'm going to just go back and do these steps that got me this answer in the beginning. This was, nope, that's not right. This was the first one. So now I've got equals, did that work? 55.9, that was that first one, okay? Then I did 180 minus 71 minus answer. Okay, good. Then I did 162 sine of that number divided by sine 71 equals, okay, I've got that answer back, times sine 41 bracket divided by sine 57. And I get 107.07, so 0.1. Okay, and we are talking meters in this case. That one was a lot harder. You saw what happened when I messed up the memory on my calculator, and I didn't have the answer that I needed, and how far I had to go back to re-get that exact value. And you probably don't want to do that. So let's see what would happen if I just punched in that number, 136.879, whoops, 987 times sine 53, whoops, I'm in the wrong spot, times sine 41 bracket divided by sine 57 equals, see, very close, 107.075, like those are close to 4 decimal places. So because I wrote down 5 decimal places, those are really, really close. What if I did 136.9 sine 41 divided by sine 57? Still very close, 107.1, okay? So you can see that 5 decimal places basically is going to guarantee that I get the right answer. 1 decimal place often for when I'm rounding a side length is good enough as well. But what I want to do is I want to go back and I want to round that angle just a little bit. This isn't much rounding. Rounding that up to 56 is not a lot of rounding. So let's do that. Just trust me, even if you're not following what I'm doing, just trust me that I'm rounding an angle now. Minus 56 gives me 53, okay? And so now I'm going to do, now I'm at this step, okay? 162 sine of 53 divided by sine 71. 136.83, and this is 0.87. So they're fairly far off. And now if I use 136.8 times sine of 41 divided by sine of 57, I don't get 107.1, I get 107.0. So I am off by a decimal place because I rounded way at the beginning. And if I round it over and over and over again, you know, it is going to eventually compound and you're going to be off by a little bit. That's still not very much. It can be a lot more. It can end up adding up and making you be off by a lot. So my advice is to try to be as close as you can. Try not to round if you don't have to, or keep 5 decimal places and type those in. Um, if you end up being way off because you rounded wrong, or you rounded way too early, or you rounded by too much, you might lose a half a mark or a mark or something like that. It's not going to be a lot. And generally speaking, you probably won't lose a mark at all. If you round wrong, you're going to lose a mark, but generally speaking, you won't at all. But it's something that you should be aware of. Okay, so that was 3 examples of double triangles. This is a really hard one. That's about as hard as it's ever going to get, even if I don't even know how often it's going to be that hard. Questions like this are more the type that we want to be good at. And we're going to see over the next 2 days why, because we're going to do some applications. And most of the applications we're going to do, kind of like we've seen in the past, will have 2 triangles in them. Those are the more interesting applications. So we want to get used to this first before we move on to the applications where we have to do a little bit more work, and then also often have 2 triangles. Okay. So keep in mind those 3 real important strategies. Pick which one you like the best, but think about all of them. Write them down if you have to. Like I said, try not to stare at a blank page and just stare blind, or just stare kind of for a long time wondering what to do. Think about those 3 strategies, pick one and try to employ it. That's the best thing that you can do to figure out how to do these questions.